Okay, so this paper starts from two features of today's economies. One is that production happens through long and interconnected supply chains, which of course are studied also by computer scientists. And the second part is more for the economist, if you want. There is a debate in especially macroeconomics. Many authors find that market power is large, some even say increasing in modern economies. And so the big picture question I want to ask here is, how does the first feature affect the second? So how does the network of connections across firms in an economy affect their market power, okay, and the surplus they can extract? In particular, in this paper, we develop a general equilibrium model of oligopoly with firm-to-firm trade and endogenous market power. I will tell you what it means in a second, using competition in supply and demand functions. And why should one be interested in this? Because this model has a features that is not easy to find in the using other techniques, especially in the macro literature, which is that all firms will have some degree of market power in all the markets they are involved in, okay, bilaterally, in an endogenously specified way. And as a consequence, both the size and the split of the surplus will depend on the primitives, okay, in every trade relationship. Let me try to be a bit more concrete on this. So in the right, for me, part of the slide, I represent a portion of the input-output network of firms. So the arrow represents the flow of goods. And now the question is, we want to understand how the price is formed in each of these links. And in particular, let's focus on the link between firm U and D. Okay? So firm U would like a high price, firm D would like a low price. But how can they do this? So a very common approach in also both the macro literature and some part of the IO literature is to assume that, well, firms decide the price when they sell, and when they buy, they take a price as given. Okay? This is common in a lot of papers. Okay, so in a sense, you assume away the problem. You think market power in a unilateral way. You assume market power is unilateral. And the typical other solution is assuming some variation of a bargaining model. So either Nash or Rubinstein, or the mixing with oligopoly game, which is the Nash-in-Nash concept, which basically assumes that you have to assume a bargaining weight that decides how the surplus is split across firms in the relationship. Okay. Here I do something different, which is a technique that comes from finance and IO, which is called competition in supply and demand functions. Okay. And yeah, let me go on quicker on the literature because there is not that much time. So in this paper, I introduce a parametric functional form for the technology in which this game firms will play, in which the strategies are functions, will actually have a simple form in which these functions will be linear in equilibrium, and this adds a lot to tractability. And then one can prove an existence result and study mergers. I will not focus on that today because of time reasons. Instead, I want to focus on the second set of results, which I think are the ones that give some insight on the how the network affects market power and why you would want to use this model rather than others. The point is that this model is kind of flexible. You can quickly embed in this type of competition many standard assumptions that people have been used, such as assume that firms take prices given when they buy. The only thing you have to do is assume that firms misperceive the slope of these functions submitted by others. Okay? As for example, a very classic model in IO, which is the sequential corner model, will be a special case of this model for given misperceptions. Then you can study the effect of these assumptions that people have been using on market power. Okay? And for example, in a chain of sectors, you can show that if you take input prices as given or output prices as given, you get opposite predictions on markups and markdowns and on the welfare impact of mergers. Okay? And rather, instead here, you have market power that has both on inputs and outputs in a flexible way. And so somehow you are putting a lot less structure on the problem as a model. And also, if this is also important for quantification of how much distortions there are due to market power, because this model first will be completely strategic about their network position, which is something that in a lot of macro models of the input-output network, you have to assume away. And one can show that if firms are more strategic, then the final price will be larger. So in a sense, we might be missing a lot of the distortions. Okay. The model is on a general network, but in this talk, I will focus on this simple network because all the insights are already here and there is much simpler to explain. So let's focus on this simple supply chain. There are two upstream firms that produce the same good that is sold to the downstream firms. Okay, that they buy it and they simultaneously use it to produce an output that is sold to consumers. Okay, so all is simultaneous. First, we'll play a game. And the simultaneous game firms play has strategies that are schedules. Okay, what does it mean? It means that the upstream firms will each submit a supply function, okay, which is a commitment to serve specified quantity of the output for all the prices that can realize for good U. Okay? And simultaneously, the firms D1 and D2 will choose two things, a supply function for their output and a demand function for the input, okay, that have to satisfy a technology constraint. It works in the same way. They specify which kind of quantity they want to trade for the prices that can realize. Okay? Now, crucially, these are not the solutions of price-taking optimizations, but these are really the strategic variables of firms. Okay, and now these are parametric assumptions that allow to have a linear equilibrium, so they gain a lot in tractability. So for the upstream firms, this is very standard. You assume that the technology is has a quadratic cost, which is very common. For the firms that have both input and output connections, this is a bit more involved. The assumption can be explained in a simple way like this. So the firms in the downstream sector will produce a quantity Q of output using a quantity Q of input. And simultaneously, to produce this quantity of output, they also have to use a quantity of labor that is quadratic in the amount of input they use. Okay? And this is key to have a linear quadratic profit function that will be key for tractability. Okay? This can be rationalized with a technology that features perfect complements and perfect substitutes. There's no time to go in there today. That rationalizes why the labor demand has this form. Okay? Essentially, some units of labor will be complementary in a decreasing returns way to the input that you want to produce. You can think of it intuitively as the cost of storing, handling, dealing with a quantity of input, and this cost is convex in how much input you buy. So this is true for each input you have. Okay? This can be generalized to when you have many inputs, including assumptions like complementarity or substitutability, which I don't show here to stick to the bare bones of the thing. Consumers will be very simple, so they are price takers, and they have essentially a linear demand function. That's what we are going to use, and the labor market is competitive. So all the complication is in the trade between firms. Okay. Now, so for this presentation, we assume that first directly choose their linear schedules. Okay, so essentially, since here all the firms trade just the upstream firms trade one good, and the downstream firms they buy one good and they sell another, but with a technology constraint, essentially they have to choose one number, which is the slope of their supply demand function. Okay, BU for the upstream and BD for the downstream. Now, this you can see as a unrestricted equilibrium of a more general model in which there is uncertainty. Then you can show that this equilibrium remains if you consider firms that can choose any kind of schedule. Okay, but this is more technical if you want. What is this? Okay, so the strategies are the schedules or slopes. What are the payoffs? The payoffs are the profits. Okay, where the quantities are specified by the schedules firms commit to. Now, what are the prices? The prices are those that satisfy the market clearing conditions. Okay. So given everyone's choice of schedules, okay, you can think of a market maker that collects these schedules, but these are the rules of the game here, and you put them in the market clearing condition. For each choice of schedules, this will output a set of prices. That is what you use to compute your payoffs. Okay, but then first internalize all of this. This is a game, so they will choose their schedule to try to affect prices in their favor. Let me throw a picture to try to give you an intuition of how this works. So let's focus on firm U1, on the best reply problem of firm U1. Okay? So all the other firms have chosen some schedules, the downstream firms demand and supply, and the upstream firm U2 another supply function. Okay? When you aggregate all these schedules together, from the perspective of firm U1, all that matters is the residual demand. Okay? There will be a curve, which is the blue line there, which represents the residual demand, how the demand for firm U1 changes for different prices, okay? And this will give rise to a profit function, okay, in terms of the price, which can be represented by the blue curve there. Now, remember, the strategic variable is the slope here, but essentially this is the same thing as, so a monopolist that faces this residual demand will have an optimal price that you want to implement, right? That will be the optimum of the profit function, so PU star there. Now, the point is that by choosing the right slope, that firm can implement the monopoly price. Okay? It's just sufficient to choose the function that crosses the residual demand exactly in the desired point, which is the one that gives rise to the price PU. Okay? Now, what's the point? Okay, and this generates a markup, that's marginal cost and so on. Now, this is out of equilibrium, okay? This is a best reply. Now, the point is that in equilibrium, the other firms will best respond to this choice of the schedule. This will change the slope of the residual demand firm U1 faces, okay? Now, what happens is that exactly as before, this will generate a profit function and an optimal price that the firm wants to implement. And for implementing this price, you will need to choose a different schedule. Okay. So all this adjustment process at some point will, converge, and you can prove that. And it converges to the point in which the monopoly price firm U1 wants to choose for the given slope of the schedules of others is exactly the monopsony price, if you want, that the buyer firms would like to choose for the slopes of the sellers and of the others. Okay, so the slopes adjust in such a way that people agree on the price that they want to be there. I'm not sure if this helps, but okay, one could, or otherwise you can write the first order condition and show things there. But a key feature of that is present here is, in passing, that is shown here is that this will be a game of strategic complements. Okay, this is crucial for all the technicalities in a sense. When other firms choose a steeper schedule, your incentive is to choose a steeper schedule. Okay, and this is the key technical property that survives also with many inputs and many outputs that allows to prove existence and to do all the comparative statistics that will follow. How many time do you have?
You have 11 minutes.
I have 11 minutes.
I have 7.
Okay. Okay. Let's go. Okay, so again, I want to skip the existence because of 7 minutes and go directly to the implications. Okay, and so in this supply chain, what happens in equilibrium? Okay, so both the firms will charge, the downstream firms especially, both a markup on the output. Okay, there will be a gap between the price and the marginal cost, but also a markdown on the input. So there will be a gap in which the input price and the marginal revenue product of the input simultaneously. Okay, and the firm's upstream will be the same, but in this case, the firm's upstream adjusts labor as an input. So in that case, it's trivial. Okay, so they have market power in a heterogeneous way in both markets they are involved in, and in a chain network, even a longer one, what you get is that markups will be increasing as you move upstream away from the consumer, and markdowns will be increasing as you move away from, as you move towards the consumer. Okay. And what is the intuition? The intuition is the following: the more you move upstream, okay, the more when you try to increase the price, this price will generate a pass-through effect in all the downstream sectors. Okay. And so the more pass-through effect you have, the more sectors these you have in front of you, the smaller elasticity of demand this generates with respect to the downstream firms that have just the demand of the consumer. So there is no pass-through there. And so the more you move up, the smaller the elasticity of demand, the larger the markup you can charge. The same effect happens with the markdowns in a reverse way. Okay. Now these two things are there simultaneously, and this effect is there also for more general networks. And essentially, then the network shape will take care of deciding then which profits are larger. In this case, if you choose a situation where firms are symmetric in every respect, the same size, same parameters, in this case, for these networks, the profits and the welfare impact of mergers will be the same both upstream and downstream. Okay, and now this, okay, now you can go to trees, you can do simulations in more general networks in which this balance is composed in a different way. But now, why this should be interesting? Because think about the more standard model, which is the sequential Cournot model. Essentially, the sequential Cournot model you can replicate here just by assuming that firms don't have market power on inputs, so they cannot affect the input price. Okay? And this will be a restriction on the slope that they can choose. Okay? In that case, you just have markups, and it remains the feature that markups are increasing upstream, but you have no markdowns. Okay? So you just have the elasticity effect on one side of the market. So in that case, you would predict higher market power upstream and also the higher welfare impact of mergers. But now the point is, if you really have strong opinions on, if this is really a market that works in that way, so it's a procedure that says the upstream firms decide the price and so on, well, that's the model, and so be it. But if you're trying to model a general connection among firms, maybe among many sectors of the economy, then it's much harder to justify assumptions on who decides the price on what. Okay, and in that case, if you do the reverse exercise of having firms that you shut market power on outputs, you get exactly the opposite prediction. Just the markdowns remain that are increasing, moving to the consumer, so market power is stronger downstream there. Okay, but the point is that these are all artificial effects that come from the fact that you are choosing a model that looks only on one side of the market and not the other. Okay, instead here Okay, so the key feature of this model is that this is a letting in principle. Firms have market power in all the markets. Okay, and this is the model that specifies how much and how these are composed in the relative market power of firms in equilibrium. This will be 3 minutes. Okay, okay. Then you can do another. Let me see if I want to say this or. Okay. Then another second exercise you can look at is that so far firms are completely rational in the sense they understand the effect of their choice in all the markets they are involved in and not involved in. Okay, they internalize the market clearing conditions, which means that they understand the pass-through effect of their choices in all the network. And this is somehow the polar case with respect to many macro models in which firms essentially take as given what happens in other sectors. This, of course, this statement is very vague. It depends really on how the model is written, but many models work in that way. I can go in details later on if you want. And so you can compare to understand what is the role of this assumption, what is the implication of these assumptions. Again, also here it's easy to implement this variation. You can just assume that firms take as given prices of the markets they are not involved in. In this case, think about firm U1, and you can compute a different model in which firms U1, when making their decisions, take as given the downstream price charged to the consumers. Okay, and the key difference is that the pass-through effect I was mentioning now is smaller because firms don't realize that when firm U1 increases the price, firm D2 will increase the price also. Okay, and so firm U1 will predict to have a higher elasticity of demand, and so will be able to charge a lower markup. And this is true, through the strategic complementarity effect. This intuition becomes an equilibrium result, which is actually true in any network. Okay, and basically you can show that in a model in which firms take as given what happens in other markets, the final price is smaller. And also, in some examples of a line that becomes infinitely long, you can get the relative welfare goes to infinity across the two models. And so what's the point of this? The point of this is to say, if you use models where, if you have a continuum of firms in each sector, which happens in a lot of macro models, it's reasonable to think that there is not much spillovers and strategic effects across other markets in the supply chain. But if you have a supply chain in which at each layer there is 1-2 firms, okay, like in very specialized environments, then it's harder to justify that firms take as given whatever happens downstream, and this has important implications for the quantification of market value. Okay, and then just to conclude. So the key message, I think, is that competition in supply and demand schedules can be useful to model competition in a network. You can deal with general firm-to-firm networks, and it's also easy to include standard assumptions that here are bound rationality assumptions. Okay? But these restrictions on market power can really change implications for quantification of distortions, and things are not the time to show, but you can have examples in which this changes the implications for horizontal mergers, productivity changes, and vertical mergers. Okay? And I am done.